it was not really difficult to create this first component. But because we have to repeat all these steps many times to create the remaining components, this task can get very tedious, time consuming, and boring. So in order to ease the task, we have to make 3 major improvements to our workflow. The first thing will be to create a specific template for sheet metal components so that we do not have to select the material and input the thickness every time. The second thing is to make sure that we will stay inside the assembly environment until we create all the sheet metal components and copy the necessary sketches inside each component, so that when we get to edit in place each component, we don't have to jump back and forth between the sheet metal environment and the assembly environment. And the third thing will be to make sure that when we will enter the sheet metal environment, we will be entering directly in the order mode instead of synchronous mode, so there will be no need to switch to order mode. Okay, so the first thing we are going to do is to create a template, and to do that you need to know first where Solid Edge stores the templates inside your drive. And a quick way to check this is to move to the application button, then select Solid Edge options, and inside file locations, this user template show you where your templates are located. So for me, they are inside the C drive, and there is a folder SE106 template. This is where my templates are stored. So I will just cancel and then go to application button, then open, and as you can see, I have the folder template already open, and it is in my C drive SE106, and then the folder template. And what we are going to do next is to select this ISO sheet metal template and hit open. And now the very first thing to do is again to move to the application button and hit save as. Don't do nothing else, so this way you avoid to screw up your default template. Okay, so we change the name to spiral casing so that we will always know why this template was created. Okay, so spiral casing sheet metal. Okay, and then hit save. Now we will define the material properties and the thickness of our components. So again, application button, this time properties, and material table. So the material we select previously, steel structural, we are going to do the same. And inside the gauge tab, we will move down to material properties and input 12. We will leave the other settings to the default value. It is not really important for our tutorial to tweak these values. Then to finish, we will select apply to model and let Solid Edge populate the change. Now we will save our new template and close it to go back to our working assembly. The second improvement is to make sure that we will always stay in the assembly environment until we create all the sheet metal components and copy inside them the necessary sketches. The first part of this step is really easy. We just have to create part in place, and what we don't want is to have this dialog pop up every time. And we also want to make sure that we create the component and stay in the assembly. So early when we create our first component, we should have set this to create component and stay in assembly. Okay, the next thing we will do is to activate this option. Remember my selection and do not show this dialog again. So we will not have this create part in place option dialog box popping every time we create a new component. And we'll say okay. Now because we define a template, we can get it directly from there. So we will select spiral casing sheet metal template, and as you can see, the material is already populated. And now we can go ahead and create the next component using the right click, and all we have to do to finish is to enter the name of the component. It will be 1 2. That means between sketch 1, which is not created yet, and sketch 2, and I will hit save. Now the component is created. We are going to drag the first component and drop it on top of the first one, so that they will be reordered in a more logical way. Okay, so next we will create the remaining components. As you can see, the template is already the correct one, so right click and rename the part 3 4, save. Again, using this time the radial menu, right click 4 5, save. Radial menu again, right click 5 6 and save. Radial menu, you can see you can go really fast with the radial menu. 6 7, save. Right click 7 8, save. 8 9, 9 10, oops, not that, 10 11, 11 12, 12 13, 13 14, 14 15, 15 16, 16 17, and then 17 18. We are going to stop here. Okay, now all the empty components are created. We will copy the sketches inside those components, and this is the second step of the improvement we are making to our workflow. So we're going to start with this one, the first component, and we will only copy sketch 2 inside this component. So we select copy sketch, and we will copy the sketch 2 inside part 1 2, see, okay. Copy sketch, we will select sketch 3, and then the part is 3 4, okay. Next, copy sketch again, this time select sketch 4, and we will apply sketch 4 to these two parts. So I will press down the control key, select 3 4, and then 4 5 and okay. So as you can see, as we are making progress, the chain icon appear in front of the path. Okay, maybe to easier our task, we will hide the master sketch. So select it, right click and select hide. Okay, next we will copy sketch 5 inside part 4 5 and 5 6. Again, copy sketch, make sure that we locate sketch 5 and then inside 4 5 and 5 6. Okay, again this time it will be sketch 6 to 5 6 and 6 7. Okay, then it will be, as you can see, sketch 7, which is the command between this part and this one. So this is how I know what I should copy every time. So 7 between these two. Okay, then again this time the sketch number 8. This one is 7 and this one will be number 8 between these two. Okay, and now we can go faster because we understand the workflow between these two. And this time number 10 between these two, and then number 11 between these two, then number 12 between these two, and 13 between these two. Okay, maybe I should have add the copy sketch inside my radial menu, and really easy to do. Right click, customize the ribbon, then radial menu, and I will select from all tabs and I will look from the home tab, and what I am looking for is this copy sketch tool, and I will put it just right there. Okay, and then close. Okay, now I will save to the previous theme, so you say yes, and now radial menu, copy sketch. I previously copied sketch 13, so this time it will be 14 and 14 between these two. Again 15, this time it will be this one between these two, then 16 these two, and then it will be the 17 between these two, and to finish the last one is 18 only in the last part. And there it is. Now you might want to take some time to go inside each part and make sure that you have the correct sketch link. So this in the part 1 2 should only have the sketch 2 copied inside, and it seems to be okay. So I strongly suggest you take some time to check that everything is properly copied. The right sketches are inside the right part. You may also have noticed that when I edit this part in place, we were directly in the other mode. This is because the copy sketch function works only in the other mode. That's why the parts are automatically switched to the other mode. Okay, but as the third improvement we have to make to our workflow, we still have to make sure that every time we will enter a newly created part, we will be directly in the other mode for this tutorial. So to make sure it always behaves this way, we have to move to this application button and then solid edge options, and we will locate the helpers group, and then instead of synchronous we will select other, and this way we make sure that every time we edit in place a newly created part, as I said before, we will have it automatically in the other mode. Okay, so that was the 3 improvements we had to make to our workflow. So now we can just go ahead and start building components. So I select the 3-4 sheet metal components and edit in place, and as you can see, the graphic area is a bit cluttered. We have the sketches from the assembly and the components inside the top assembly visible. We want to hide this, so we focus on what we need to create, and the way to do that is to move to this view tab and select this button, hide previous level, or using your keyboard Ctrl Q will do the same trick. So if I click on this button, as you can see, I am only left with these 2 sketches, and from there I can work easily. Okay, now we can start creating our lofted flange, and because we are going to do this quite often, we need to take some time to add the lofted flange tool to our radial menu. So again, right click, customize, radial menu, and the lofted flange is located in this sheet metal tab inside the home panel. So we go home panel, sheet metal, and then inside the contour flange we have this lofted flange tool, and we make sure that we position it as we want it. So I will choose this position, and then I'll make sure I save it in my custom theme. So save and then close. Now radial menu, I have the lofted flange tool active. Select my first profile again, and then I select the second profile, right click to accept first, then I select the second profile and make sure that the 2 starting points are correctly lined up, and then I just have to define the site where the material will be added. As you can see, because we use a template, the thickness is already defined, and then right click to finish and cancel. Now we have the second component created, so close and return, and you can see how the second component is positioned inside the assembly. We can go again inside the third component, which is actually 4-5, edit in place, and as you can see, because we activate this option, we cannot see the other component in the assembly. So lofted flange, this one, right click, second profile, right click, upward, and right click to finish, cancel. Okay, now normally what you'll do is to hit close and return, but it is not really necessary to go back to the assembly and jump inside the next part. So what you can do to activate the next part you want to work in is to just move to the next part and double click. and the next part is loaded, and now you can just create your lofted flange. How easy it is. It is far much better and efficient than the previous steps we had to go through to create the first part. Okay, again, cancel, double click to activate the next one, launch the Lofted Flange tool, select the first profile, second profile, define the material site, cancel, double click to activate the next one, Lofted Flange tool, first profile, second profile, material site, and this is really quick. This one, right click, material site, and there you go. Double click, radial menu, first profile, right click, second profile, right click, material site, and there you go. Double click. Okay, I think that by now you get the drill. So I will just go ahead and create all these components. Okay. And that's it. This will conclude this part. In the next part, we'll be adding the deflector, the ring that support all these components, and we will build this missing component. See you then, and thanks for watching.